All right, so let's see this particular question now. So in this question, we are given an integer array, and what we need to do is we need to find the smallest positive number that is missing from this particular array, right? And this array can have negative numbers or zeros, right? Anything is possible. We just need to return the smallest positive number that is missing from this particular array, right? So if you see this particular example, 2 minus 3, 4, 1, 1, 7, the smallest positive number that is missing from this particular array is 3, right? Because I have 1, I have 2, and then directly I have 4. I don't have a 3 over here, right? That's why my output is 3, because that is the smallest positive number missing from this particular array, right? So that's the question simply. Now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, see, we have to keep one observation in our mind, right? So if I ask you that what could be the largest number that can qualify to be my output, right? That can qualify to be the smallest positive number that could be missing from this particular array. What could be the upper bound, the largest element possible, right? So the answer to that would be n plus 1, right? Where n is the size of this particular array, right? And why would it be n plus 1? Why would the upper bound to the output, or the smallest positive number that could be missing from this particular array, would be n plus 1? Because consider a case if I have all the elements in this particular array from 1 to n, right? So in total I have n elements over here, that's why the size is n, right? So I will have 1, 2, 3, 4 up till n, all the elements, right? So if I have all the elements from 1 to n, then what could be the possible smallest positive number that is missing from this particular array, right? I have all the elements starting from 1 to n, right? That means it will be n plus 1, right? The next number, right? After n, right? So that's why, the upper bound on my smallest positive number that could be missing from this array would always be n plus 1. It can never be n plus 2. It can never be greater than n plus 1. It will be between 1 to n plus 1 always, right? So that is one observation that we have. Now, see, what we can do is to solve this particular question, we can follow a simple algorithm, right? So actually, let me write it over here. So what I will do is I will just scan this particular array once. I will traverse the entire length of this particular array once, right? And what I will do is in this particular traversal, at every element, I will first check if that current element is greater than n or less than 1, right? In case if it is greater than n, or if it is less than 1, that is if it is 0 or negative, or if it is greater than n, then what I will do is I will just default this particular element to n plus 1, right? I will just update its value to n plus 1 simply. So for example, in this particular array, the n is 6, right? So I will just update the value of that particular element wherever I find the element's value to be greater than n or less than 1 to n plus 1. So it will become 7 then, right? And I will just keep checking this condition at every element, and I will just keep updating that particular number accordingly wherever the condition is met, right? That I will do in this first traversal, right? So now after doing this updation, after traversing this particular array once, my resultant array, my updated array would become like this, right? It will be 2, right? Because 2 is neither lesser than 1 nor greater than n. So it will stay as 2 only. I won't do any change. Then I got minus 3, right? So minus 3 is lesser than 1. So I will just update it to 7 now, which is n plus 1, right? Then 4, I will not do anything. 1, I will not do anything. Again 1, I will not do anything. And then 7 is greater than n, and I have to update it to n plus 1, but it is already n plus 1, so it will be 7 only, right? So this is 2, 7, 4, 1, 1, 7. This will be my updated array now after doing this first traversal, after doing the first step, right? Now what I will do is I will again traverse this particular array now, right? This updated array. And now at every element, what I will do is whatever value I get at that particular index, I will go to the corresponding index in this particular array. So for example, if I got 2 over here, I will go to 2 minus 1 index now, right? So I will go to this particular index and I will just multiply whatever the value over here is to minus 1 by minus 1, right? So what I will do is over here, once I'm at my first element, I got 2. So I will go to the index 2 minus 1, which is 1, and I will just update this particular value after multiplying it by minus 1. So it will become now, uh, you know, I will just keep a blank over here, and this will become minus 7 like this, right? And now I will go to the next element, which is minus 7 now, right? It is not 7. because I have updated it now in the first iteration itself. So now see, at every iteration, when I'm actually going to that particular index equal to the current number minus 1, I will always take the absolute value of the current number, right? Because if I have already updated that particular number to minus, like if I have already multiplied that particular number with uh, minus 1, so I mean, I have to take the absolute value now to go to that particular index minus 1, right? So now I will just take the absolute value of this particular number, whatever I get over here, that will be 7. And then I will check if this particular number, the absolute value is actually, lesser than n or not, right? If it is lesser than n, only then I will, go and update the corresponding index and again multiply it by minus 1. Otherwise, I will just ignore it. I will just move on, right? So that's why over here I got like the absolute value is 7, which is greater than n. So now I will just ignore this particular number and go to the next number, right? Now over here I got 4. So now I will go to 4 minus 1, that is third index, and which will be this. And I will just convert this particular number to negative, right? So now this will be minus 1, like this, right? Now I will go to the next number, which is 1. Now 1 minus 1 is 0. So I will go to the first index and I will just convert this 2 to minus 2. So it will become minus 2 now, right? Then I will go to the next number again, which is again 1. So 1 minus 1 would be 0 again. And this number is already converted into negative. So I won't change it now, right? I will just ignore it again because this is already converted to negative, right? So now this will be minus 2 itself, right? And then what I will do is I will go to the next element, which is my 7, right? And this 7 is anyways greater than n, right? So now I don't have to do anything. I can just ignore it, right? So these are the numbers that I updated, and rest of the numbers will be as is. So I can just keep 4 over here as is, right? And 1 over here and 7 over here, right? So these numbers will stay as is because I did not find any number which was equal to this, the index of these numbers plus 1, right? That's essentially what we are saying, right? Now this is my updated array, right? And what we have done is, corresponding to every number that we got in this particular actual array, we have actually marked the corresponding indexes by negative, right? We have actually flagged those particular indexes in a way, right? So now what I can do is I can just traverse this particular, final array from left to right again. And wherever I find a positive number first at whichever index, that index plus 1 will be my result, right? Because that index actually never got updated because there was no equivalent positive number in my original array, right? And that's why I never came to that particular index to make it negative. And that's why it is still positive, right? And that was the reason I converted all the negative numbers and all the zeros to a default value, which is n plus 1, right? Because I just wanted to use this fact that whichever numbers at the end I'm not updating to negative, right? That those numbers will be missing from my original array, and I want to find the first such index, right? Because that will be corresponding to the smallest positive number that is missing from my array, right? So that's the intuition behind this particular solution. I hope you understood it well. What we are trying to do, we are just trying to make use of the indices of the array itself, right? To mark if we have seen the corresponding number in the array or not, right? So that is what we are trying to do over here, right? Now, if you talk about the time complexity over here, so see, we are just scanning this particular array multiple times, but then that is, I think, just 3 times we have, scanned this particular array. So again, the time complexity will be big O of n, right? And talking about the space complexity, we haven't used any extra space, so it will be order of 1, right? So that is the entire solution. And also, maybe you can just try to still think of a different solution also, right? If you can do it in lesser traversals, right, less than 3, you can just give it a thought, maybe. But this anyways is order of n and order of 1 solution, time complexity being order of n and space complexity being order of 1. So it is an efficient solution, right? So now maybe let's jump to the IDE and code this particular solution. All right, so now let's implement the solution that we discussed. So first of all, let me just declare a function. I will call it as missing number, right? Like this. And this will accept an integer array. And as a first step, I will just capture the length of this particular input array in a variable n, right? And now what I need to do is I will just traverse this entire array, right? And then at every element, I will just keep checking if my current element is either greater than n or if it is, lesser than 1, like this, right? And in either of the cases, I will just update my current element to n plus 1, right? Which is nothing but the size of the array plus 1, right? This is what I'm going to do. Now, I will again iterate over my updated array, right? So I will again, you know, just go from 1 to n, 0 to n, right? And now what I have to do is at every element, I have to go to the index which is equal to that particular current element minus 1, right? And multiply that particular value, whatever I got over there in the target index, by minus 1, right? So that's what I have to do. But before actually referring to that particular element, which is sitting at, the current element minus 1 index, I will just check if my absolute value of the current element, right, minus 1 is actually lesser than n, right? Like this. And this minus 1 will be outside, like this, right? Because if it is not lesser than n, and if I try to go to that particular element and try to update it, I will get an index out of the range error, right? So that's why I have to first check this particular condition, that if the absolute value of my current element minus 1 is actually lesser than n, that is if it is a valid index or not. In that case, I will just go ahead and update, you know, this particular value, yeah, like this, minus 1, and I will just multiply it by minus 1, right? That's what I'm going to do. And also one more thing I have to check before doing this updation, that if, this particular element, which is sitting at absolute value of the current element, sorry about that, current element minus 1, whichever element is sitting at this particular index, if that has been already updated to negative, right? So in that case, I don't have to do anything, right? In that case, I can just ignore it. And so I will just put a condition over here that if this particular value that I am getting over here, if this is, already negative, right? So if it is greater than 0, only then I'm going to do this. If it is negative, I'm going to just ignore it, right? That's what I'm doing over here. And now once I'm done with this, I've updated all the elements of the array. Now I will again loop through my array, right? Like this. And now what I will do is I will just look for the first positive integer, in this particular array. And the moment I get that, I will just return its corresponding index plus 1. And that will be my smallest positive integer missing from the original array, right? And now if I don't get anything, right, if I don't get any positive number in the entire array or everything is negative, it would mean that all the numbers from 1 to n were actually present in my original array. And so now my smallest positive number which was missing from the array would become n plus 1, right? Which is, the length of the entire array plus 1, the next number, basically, right? So that will be my entire code. Now maybe we can quickly test it. We can declare a sample array over here, the same one that we used in the explanation also, right? So I will just copy it from here. And now I can just print the output of this particular function by calling it over this particular array, right? And the smallest missing number over here is 3, right? So my output should be 3 over here. If I run this now, so I get 3 as the output, which is the correct output, right? So this is entirely the solution for this particular problem. I hope you understood it well. And now I will see you in the next video. Thank you.